when finding the rational zeros of each function, we first have to look at the possible zeros this function could have. We go back to P over Q. That would be all the factors of 42 versus all the factors of 1. So that'll be 1, 2, 3, 6, 7, 14, 21, and 42. Then we look at the change in signs. So it goes from a positive to a negative here. So there's 1 change of sign. It goes from a negative to a negative, so that's not. A negative to a positive, that's a second. So we have a possible 2 positive, and then with 3 total zeros, a negative. So we really could kind of test anything we wanted here. You want to go in some sort of order and not jumping around. Easiest thing to do is to start evaluating the function for each of these different numbers. So we plug in 1 for x. I have 1 to the third minus 6 times 1 squared minus 13 times 1 plus 42. So 1 minus 6 minus 13 plus 42 is 24. That tells me that 1 is not one of the zeros because I should get 0 here if it was a 0. So next I'm going to try negative 1. Negative 1 cubed minus 6 times negative 1 minus 13 times negative 1 plus 42. And that gives me 61. Still not 0. So positive and negative 1 are out. Let's try 2. 2 to the third minus 6 times 2 squared minus 13 times 2 plus 42. And so 8 minus 24 minus 26 plus 42 gives us 0. That is one of the zeros then. So we're going to start with 2. In the box, 1, negative 6, negative 13, and 42 up above. Drop down our 1. 1 times 2 is 2. Add that, we get negative 4. Negative 4 times 2 is negative 8. Add that, we get negative 21. Negative 21 times 2 is negative 42, and our remainder is 0. That's what we would expect to find, because when we plug 2 in and evaluated it, we end up with 0. The reason for the work here on the right is because this is very easy to punch in the calculator to do quick checks to find out which number I want to try and start with to break this down. So I've broken it down. I have one of my zeros. I need to see if there are any other rational zeros. Rational meaning it's either an integer or a fraction. So here we have x squared minus 4x minus 21. I can do one of two things. I can use the quadratic formula, or I can see if that's factorable. So I'm going to check for factoring. It needs to multiply to a negative 21, add to a negative 4. So we can get a negative 7 and a positive 3 out of that. Again, because that's 1x squared, I can make that x minus 7 and x plus 3 equals 0. I set each factor equal to 0. X minus 7 equals 0. X plus 3 equals 0. Add the 7. So x equals 7. Subtract the 3. X is a negative 3. So I have 3 rational zeros here, and they are negative 3, positive 2, positive 7. So this one, all 3 of the zeros are rational. Your total number of zeros possible should not be bigger than the index. So this is x to the 3rd. So at most, I can have 3 answers here. This is what I look for my final answer on this one. So P over Q, again, I want to look for the possible. I'm going to start with all the factors of 12. This would be P over 1, and then I can go back and put it over 2 if I want. Now, what I'm going to do is I'm not going to worry about the fractions just yet unless I get through and exhaust all my options. The one thing I noticed with number 2 is that every term is positive, which means since there are no changes in sign, any rational zeros that I'm looking for are negative. So I'm not going to want to try any positive values here. So I'm going to start with negative 1. So f of negative 1 equals 2 times negative 1 to the 4th plus 11 times negative 1 cubed plus 26 times negative 1 squared plus 29 times negative 1 and then plus 12 there at the end. When I go through and check all of that, I'm going to have 2 minus 11 plus 26 minus 29 plus 12, and that gives me 0. So negative 1 is the first number I'm going to put in the box as one of my rational zeros. So 2, 11, 26, 29, and 12. Drop my first number down. I have 2. 2 times negative 1 is negative 2. I get 9. 9 times negative 1, negative 9. 26 plus negative 9 is 17. And we have negative 17. 29 plus negative 17 is 12. 12 times negative 1, negative 12, and 0. So now I'm sitting with the problem 2x cubed plus 9x squared plus 17x plus 12. I have 4 terms, but that's not factorable by grouping. So then I need to go back to my list of P over Q and see if I can break this new one down further. I could try negative 1 again. And negative 1 doesn't give me anything, so now I'm going to go with negative 2. And I'm trying it on the new one. There's no reason to go back to the original because I've already broken this down further. So 2 times negative 2 cubed plus 9 times negative 2 squared plus 17 times negative 2 plus 12. So we have negative 16 plus 36 minus 34 plus 12, that's negative 2. So that doesn't give me what I want on that one. All right, so if we keep going, negative 2 did not work. So I'm going to go back and try, let's try negative 3. 2 times negative 3 cubed plus 9 times negative 3 squared plus 17 times negative 3 plus 12. And that gives me negative 12. So at this point, I notice that my values are getting bigger when I evaluate them, as far as smaller numbers going. So the bigger I make this, the bigger it's going to be. I don't see that happening and working out. So I'm going to jump and let's look at the fractions of P over Q. So each of these numbers, 1 through 12, 1, 2, 3, 4, 6, and 12, I've got them all over 1. So now let's go back and put them over 2, which is the other factor for Q. So I have 1 over 2. 2 over 2 is 1, so I don't worry about that. I have 3 over 2. 4 over 2 is 2, 6 over 2 is 3, 12 over 2 is 6. So those are the only 2 new ones I need to work out. Again, no change in sign. Those are all positive, so I'm going to want to deal with the negatives. So I'm going to try and evaluate these for negative 1/2 and then possibly negative 3/2. So f of negative 1/2. So 2 times negative 1/2 to the third plus 9 times negative 1/2 squared plus 17 times negative 1/2 plus 12. And that gives me 5 1/2. So not 0. So then we go through negative 3/2. Going through the same process. And I'm going to do 2 times negative 3/2 cubed plus 9 times negative 3/2 squared plus 17 times negative 3/2 plus 12, which thankfully gives me 0. So negative 3/2 goes in the box. And I break this down. 2, 9, 17, and 12. Bring down 2. 2 times negative 3/2 is negative 3. Then I have 6. 6 times negative 3/2 negative 9. So then I have 8. Eight times negative 3/2 is the negative 12, and there's 0. So I have 2x squared plus 6x plus 8 equals 0. I'm only looking for rational zeros. So if this trinomial is not factorable, then we're done. I'm going to make this a little easier and divide everything by 2 so that I have x squared plus 3x plus 4 equals 0. So I need things if they multiply to 4 and add to a positive 3. 1 plus 4 is 5, and 2 plus 2 is 4. So none of these will do this. So this one only has 2 rational zeros. The -1 I found at the beginning, and the -3 halves I just found at the end. We will get to a point where we are finding all the zeros, but here we only want the ones that are rational, that we get through factoring these. All right, working them out with P over Q. First, I need to figure out what do I even want to look for. So the factors of 5 over the factors of 3. So we have 1 and 5. Then we have 1/3 and 5/3. This is where we're just going to go through and work and plug in, see what we end up with. So I'm going to work with the positive numbers first. So evaluate it for 1. 3 times 1 cubed minus 2 times 1 squared minus 8 times 1 plus 5. So 3 minus 2 is 1, minus 8 is a negative. Altogether, that gives us a -2, so that doesn't work. And next, go to 5. 3 times 5 to the third minus 2 times 5 squared minus 8 times 1 plus 5. So again, 8 times 5 there, so that gives us positive 43. Still not what we want. So let's look at the 1/3. So 3 times 1/3 cubed minus 2 times 1/3 squared minus 8 times 1/3 plus 5. Gives us 29ths, so definitely not something we can work with. Hoping that 5/3 is going to work here. So 3 times 5/3 cubed minus 2 times 5/3 squared minus 8 times 5/3 plus 5. And we found our 0. So we're going to put 5/3 in the box. 3, -2, -8, and 5. I drop down the first number, 3. 3 times 5/3 is 5. -2 plus 5 is 3. 3 times 5/3, 5. -3. So then -3 times our 5/3 is -5, remainder of 0. So I have 3x squared plus 3x minus 3. I'm going to divide everything by 3 to make things smaller to work with. So that's x squared plus x minus 1. So again, only looking for rational zeros. So to find another 0 that's rational, this has to be factorable. So it needs to multiply to -1, add to a positive 1. There's nothing that's going to do that. So I only have one rational 0. So 5/3 is the only answer I'm going to put down here because it is the only rational 0 in this polynomial. All right, so this one, there's a lot of factors with 75 matching up against the factors of 4. However, there are 4 terms, and it's possible to factor these by grouping. So that's something you always want to keep in mind to save you some time on trying to find all possible zeros that could work. And I look at this, if I divide 175 by 25, I get 4, 3. So I get the numbers that I'm wanting. So I set it equal to 0. And look at them at 2 at a time. So on the first 2, I'm going to factor out an x squared. So I have 4x minus 3. The next 2, I want to factor out a negative 25. And I have 4x minus 3. So I have 4x minus 3, x squared minus 25. I can set these now equal to 0 and solve. 4x minus 3 equals 0. X squared minus 25 equals 0. On the first one, add the 3. Divide by 4. The next other one, add 25 to both sides. Take the square root of both. So x is a positive or negative 5. So I have 3 rational zeros here. I have positive and negative 5, and I have 3/4. So you don't necessarily always have to use P over Q. All the other factoring options are still available if you recognize the pattern. So on the next one, no, there are not, this is not factor by grouping. So we do need to look at possible zeros. We start with listing P over Q, which in this case is just all the factors of P. So 1, 2, 4, 7, 14, and 28. I've got 1 change in sign, so I definitely have a positive number. So let's go through and see what we can find here. So evaluate it for 1. I have 1 to the 3rd plus 4 times 1 squared minus 25 times 1 minus 28. That gives me negative 48. So definitely not something I can work with. So let's try negative 1. Negative 1 to the 3rd plus 4 times negative 1 squared minus 25 times negative 1 minus 28. This one gives me 0, so negative 1 is my first rational zero in the box. So 1, 4, negative 25, negative 28. Drop down to 1. 1 times negative 1, negative 1. Add those two, we end up with 3. 3 times negative 1, negative 3. I get negative 28 when I add those two. Multiply, I get a positive 28, remainder of 0. So x squared plus 3x minus 28 equals 0. I needed to multiply to negative 28, add to a positive 3, that'll be a positive 7, and a negative 4. So x plus 7, x minus 4, set each factor equal to 0, and x minus 4 equals 0. Subtract the 7, and add the 4. I have 3 rational zeros. I have -7, -1, and 4. Okay, so the next one, 4 terms. 1x cubed plus 6x squared, 4x plus 24. I see a possible factor by grouping pattern. On the first two, I'm going to factor out x squared, leaving me with x plus 6. On the next two, I'm going to factor out 4, also leaving me with x plus 6. I have x plus 6 and x squared plus 4. I can set each of these factors equal to 0. When I do, I'm going to subtract the 6 on this first one. That one's finished. I'm going to subtract the 4 on the next one. I'm going to take the square root of both sides. So x is a positive or negative 2i. Keeping in mind, I'm only listing the rational zeros. So I only list -6. 2i is not a rational number, it's an imaginary number, so we leave it alone and leave it